To withstand sub-zero Arctic blizzards, every survival shelter begins deep within the frozen earth, where high-grade structural iron ore is extracted under extreme conditions. Simultaneously, specialized chemical facilities synthesized dense thermal polymers, creating the specialized chemical foundation required for zero-degree exterior insulation and structural seals. Precision machinery harvests the raw ore, selecting only dense, unyielding mineral deposits, capable of forming the high-tensile steel skeleton needed for severe structural stress. Each batch of raw material undergoes immediate tactile and visual assessment, ensuring the density and purity meet strict standards before transport to the refining center. The liquid polymer compounds are pumped into temperature-controlled tankers, preserving their precise molecular stability during long-distance transit to the main fabrication plant. Arriving at the main next-gen manufacturing facility, raw materials enter a climate-controlled environment designed for precise modular shelter construction. Overhead cranes unload the massive steel girders with effortless precision, organizing the structural components for immediate automated testing and surface preparation. Bulk polymer pellets are dumped into automated feeding hoppers, destined to become the high-performance closed-cell insulation core that seals out freezing Arctic wind. Before fabrication begins, automated laser inspection systems map every steel girder in 3 dimensions to detect microscopic structural flaws or dimensional variance. Robotic transfer units sort the approved steel according to load-bearing specifications, routing primary frame members directly toward high-temperature cleaning and prep. Steel beams enter an automated abrasive blasting chamber, where high-velocity steel grit strips away rust, scale, and surface contaminants to ensure raw metal purity. Following abrasive treatment, high-pressure steam and chemical degreasing jets wash down every surface, leaving a perfectly pristine foundation for subsequent corrosion-resistant coatings. Macro cameras verify the micro-textured surface profile of the cleaned steel, confirming optimal surface roughness required for maximum adhesion during structural welding and bonding. The primary exoskeleton build begins as heavy-duty multi-axis robotic welder's position around the main steel frame, executing continuous structural welds along primary load joints. Bright orange spark showers fill the cell as high-amperage arc welders fuse corner gussets, creating a rigid sub-zero structural cage capable of resisting extreme Arctic wind loads. Simultaneously, high-pressure reaction vats blend specialized polyurethane thermal compounds, precisely controlling chemical temperature and viscosity prior to closed-cell mold injection. Heavy hydraulic presses deliver hundreds of tons of downward force, stamping raw aluminum sheets into corrugated, wind-deflecting exterior wall cladding panels. The mixed thermal polymer is injected into sealed wall molds, rapidly expanding and hardening into dense, zero-degree insulation panels that permanently eliminate thermal bridging. Completed wall and frame sections enter an automated electrostatic booth, where specialized polymer powder is sprayed evenly across all surfaces to resist sub-zero moisture penetration. Emerging from high-temperature curing ovens, the matte, powder-coated steel and aluminum panels reveal a durable, weatherproof finish ready for high-precision cutting and structural assembly. Precision cutting begins as ultra-high-pressure water jets slice through triple-pane, aerospace-grade glass, ensuring absolute millimeter tolerances to prevent vacuum seal failure under extreme thermal stress. Automated diamond grinders polish every pane perimeter, eliminating microfissures that could compromise structural integrity when exposed to rapid sub-zero freeze and thaw cycles. In an adjacent bay, multi-axis CNC routers trim hardened foam panels, carving interlocking joinery channels that guarantee an airtight seal between every modular wall section. The welded steel exoskeleton advances into the main joinery hall, where pre-cut wall sections, floor foundations, and roof structures converge for modular assembly. Heavy gantry cranes position the insulated roof panel onto the steel framework, where heavy alignment pins lock the structure together within tight structural tolerances. Assembly technicians secure the primary frame using high-torque pneumatic impact drivers, torquing heavy stainless steel fasteners to rigid structural load specifications. Human craftsmanship takes center stage during delicate sealing phases. Skilled artisans hand-apply specialized thermal caulking, eliminating potential cold air infiltration channels around window apertures. Inside the floor assembly, technicians thread high-efficiency copper heating cables into insulated grooves, laying the foundation for an interior radiant floor system designed to defeat Arctic frost. Composite floor decking is installed over the radiant heating grid, providing structural stability while trapping thermal energy directly within the living envelope. Multi-layered rubber weather stripping is hand-fitted into the heavy vault door perimeter, creating an impenetrable pressure seal against howling 0-degree wind gusts. Internal climate systems are integrated into the shelter frame, installing heat exchangers that recycle warmth while continuously circulating fresh, clean air throughout the sealed environment. With structural assembly complete, the shelter moves into the sub-zero environmental testing bay to verify thermal isolation performance under extreme simulated Arctic conditions. The heavy chamber doors seal shut, isolating the structure inside an airtight, temperature-controlled environment designed to duplicate the world's most unforgiving winter storms. Industrial cryojets spray sub-zero freezing vapor directly onto the exterior shell, plunging surface temperatures down to 0 degrees and beyond within minutes. Calibrated thermal imaging monitors verify zero heat leakage across wall seams, confirming that interior heat remains completely locked inside the living capsule. Digital barometric sensors track cabin air pressure, proving the perimeter seals prevent cold draft penetration under violent hurricane force wind simulation. Passing climate certification, the shelter returns to the main bay where technicians perform final surface wipe-downs, removing frost condensate to inspect exterior coatings. A heavy stainless steel serial emblem is riveted into the main entrance frame, marking the shelter's official certification and individual build pedigree. Preparing for international transport, heavy overhead cranes drape specialized multi-layer protective tarps over the entire module to shield structural components during transit. High-capacity thermal shrink systems conform the heavy outer film tightly around the shelter contours, locking out road grime and salt spray during long-haul delivery. Heavy steel tension chains and high-tensile ratcheting straps bind the module securely to multi-axle transport beds, preventing movement across thousands of miles of rough Arctic terrain. Precision crane operations position the multi-ton shelter onto specialized heavy transport trailers, engineered to withstand extreme road vibrations and severe weather delays. The main logistics bay doors roll open into the cold winter air, clearing the path for the shelter to begin its final journey to the distant tundra. Leaving the climate-controlled manufacturing center, the convoy heads toward remote sub-zero destinations, carrying precision engineering built to defy the world's most unforgiving climates. Navigating through isolated mountain passes and frozen wilderness roads, the transport unit brings complete self-contained shelter technology to sites inaccessible to standard construction. At the installation site, heavy mobile cranes carefully lower the survival pod onto pre-driven steel helical foundations, ensuring minimal ground disturbance while establishing rock-solid anchorage. Technicians strip away the protective transport casing, unveiling the matte polymer exterior, designed to shed heavy ice accumulation and reflect extreme polar ultraviolet radiation. Structural anchor bolts are hand-torqued into foundation plates, permanently securing the survival module against severe Arctic ground heave and howling gale force wind loads. With final utility hookups engaged, the heavy vault door unlocks, opening into a fully climate-controlled sanctuary capable of maintaining warm interior living conditions indefinitely. Inside, precision craftsmanship creates an uncompromising haven of comfort and safety, proving that human ingenuity can construct an impenetrable refuge against zero-degree weather. Behind triple-pane aerospace glass, interior cabin temperatures remain completely unaffected by the howling sub-zero blizzard raging just inches away on the other side. Every continuous weld, every closed-cell polymer panel, and every hand-fitted seal works in silent harmony, creating an absolute thermal fortress against severe sub-zero climates. Designed from raw mineral origin to final modular deployment, the structure stands as a testament to advanced industrial engineering and relentless manufacturing precision. Where extreme nature demands survival, rigorous quality testing and skilled human craftsmanship ensure that life inside remains secure, warm, and entirely undisturbed. This is more than standard modular construction. It is the ultimate convergence of human craft, raw material science, and uncompromising design, built to endure anywhere on Earth. Fluxify process, from raw origin to perfected protection, engineered for the impossible.